Hello, my name is Subbareddy Darukumalli and I am ESR number 12 located at Brooker, Alicona. My industrial supervisor is Mr. Franz Elmley and I am doing PhD at University of Nottingham under the supervision of Professor Richard Leach. My research is on machine focus variation sensor development and its metrological characterization. According to the new definitions, the on-mission surface metrology is defined as the where the measurement sensor directly mounted onto the manufacturing machine. According to the conditions of surface metrology for precision engineering, the on-mission metrology sits in inline measurements, which includes the in-process, off-process, pre-process, and post-process measurement. The typical focus variation sensor consists of a specially designed optical setup together with an microscopy objective and a high precision linear motion stage. In focus variation principle, a small amount of area is scanned vertically to compute the topographical information. Here is the concept diagram of the on-mission focus variation sensor developed in this project, which consists of a specially designed optical setup together with motion controller and a built-in mini computer, which is connected to the remote computer via Wi-Fi or wired communication. The key specifications of the on-mission focus variation sensor is the larger field of view of 2 cross 2 millimeters and a less measurement time of approximately less than 20 seconds, and the compatibility to the conventional CNC to the additive manufacturing machines. In this research, we evaluated the meteorological characteristics of the on-mission focus variation sensor prototype, which includes the amplification coefficient, linearity deviation, and instrument noise as per the ISO 25178 Part 600 standard, following the ISO 25178 Part 700 procedures, and the maximum permissible unidirectional stationary error from a derived method from the ISO 10360 Part 8 standard. The instrument transfer function is also derived from the measurement error plot, including the measurement test uncertainty. We computed the maximum permissible unidirectional stationary error, which is 0.49 micrometer plus or minus length over 250 2500, where length is the L is the length of the sample in millimeters. To compute the amplification coefficient and linearity deviation, we measured a set of measurement artifacts at 5 measurement positions of the axis, following the ISO 25178 Part 700 procedures, and here is the computed values. To compute the instrument transfer function of the focus variation system, we designed a special type ASG star pattern artifact with a specific roughness on it. In step 1, the ASG star pattern was measured with the focus variation system. In step 2, the profiles were extracted at different amplitudes of the star pattern. In step 3, in each extracted profile, the lateral period limit was calculated. In step 4, where the lateral period limit falls under the 50% of the actual amplitude is computed as the instrument transfer function of the focus variation system. During this project, we published 3 conference papers and a journal paper about the instrument design and the meteorological characterization. In this research, we answered the following 3 research questions. Question 1 is determination of the meteorological characteristics of the on-machine focus variation sensor, and the question 2 is developing a method to compute the instrument transfer function of the focus variation sensor. The question 3 is designing an artifact for determination of lateral period limit in focus variation sensor. Thank you for listening. If you have any questions, contact me